All right, friends, I'm going to talk us through how to do worksheet 10. And so worksheet 10, if you go to pivotinteractives.com and you go to your My Classes, you'll see this assignment. I accidentally assigned it twice. It doesn't matter which one you do. You can do either assignment. It's the same thing. So on your worksheets, right now you should definitely have your packet out, open to worksheet 10, your iPad with Pivot open, and then you should also have your reference packet open to pages 5 and 6, because that's where the linearization notes are going to come really in handy. So if you don't have all that stuff, pause the video and get that out, your packet, your reference packet, and Pivot. All right, so the first thing on your packet on worksheet 10 is that you have a data table. I want you to cross off the data table part that is blank. I don't want you to fill in numbers on your worksheet tonight. So just for each of those problems, actually, you can cross off those like blank columns on number 1, 2, 3, and 4, because we're not going to use those. You're just going to do it on Pivot. What you are going to do is the 2 graphs or 3 graphs and the final physics equation. So that's what we're going to start with. If you scroll down from the data column, you'll see that there is a, if you just click the axis, you can then choose area. I would say in general, you're going to want to pick the left column as your y-axis and the right column as your x-axis. Do not do anything for uncertainty. Make sure your uncertainties are nothing. Okay, so when I look at this data, I think it looks kind of like a curve. It looks like a quadratic. And so when I look at my linearization notes on page 5 of my reference packet, I see that when my graph looks like a quadratic, I am supposed to plot y is proportional to x squared. So I basically need to keep my y-axis the same. So I'm not going to change the area, but I am going to change what I plot on my x-axis. So instead of plotting radius, I need to plot radius squared. So that's going to be in centimeters squared. All the things about the radius change like a square. So instead of r, I'm plotting r squared. And then I'm going to change my column formula. So again, the magic 3-dot button. Change the column formula. And I'm going to put r to the second. So r caret second. And that's r squared. And then now I have r squared. And again, you're not going to copy this in your packet. But what you are going to do is you are going to change this x-axis to be r squared. And so now that graph looks beautifully linear. And so I'm going to add a curve fit. Do not hit line graph. This is not what I want you to do. Keep it a scatter. Go to curve fit. And then you're going to change it to linear. So now this looks like a line, and I have my equation for my line. But how do I make this into a physics equation? Well, I'm going to start with my equation for a line, and excuse my terrible handwriting. I'm writing with a mouse on my laptop. Okay, so on my y-axis, I see area. And the variable I use to represent y is A, capital A. On my x-axis, I see not just radius, but radius squared. Then if I look over here, I see that my slope, or this capital A that they put right here, is 3.15. And then centimeter squared over centimeter squared, that's just 1. So these units cancel each other out. And so we're just left with the 3.15. But writing 3.15 centimeters squared over centimeters squared here is not wrong. So that's our slope. And then my y-intercept is negative, and I need my parentheses around any number, 1.51 centimeters squared. So negative 1.51 centimeters squared. Notice I put my parentheses around the whole thing, including the units, because those units are attached to the number. So between page 5 in your reference packet, and I think it's page 4 in your reference packet that has how to write a physics equation, those pages you should be referencing while you're doing this worksheet. So you have the rest of the problems for homework. Again, I said left column is the y-axis and the right column is the x-axis, but it doesn't matter too much which graph you did. All right, I will see you all tomorrow, and we will check keys for this tomorrow.